Students, now we are going to discuss one more problem related to confidence limits. So we'll see the problem. If 8.6, 7.9, 8.3, 6.4, 8.4, 9.8, 7.2, 7.8, 7.5 are the observed values of a random sample of size 9. That means they have given the sample points 9 from normal distribution with mean 8 and variance sigma square. Obtain 90% confidence limits for the population variance sigma square. Okay, so this is also requested by a student. So now what I am going to tell you is, here they are asking us to find out the population variance, confidence limits for population variance. So if you want to find out the confidence limits for population variance, we have to use chi-square distribution. Okay, so we are going to do the solution. So to obtain confidence limits, to obtain 90% confidence limits for the population variance, sigma square, given the sample points. Okay, they have given what sample data they have given us, and they are asking us to find out population variance confidence limits. Okay, sample data. So at the time we can use what? Chi-square distribution. Okay, we can use the chi-square distribution. Chi-square distribution. Okay, so this is denoted by like this. Okay, chi-square distribution. So the formula is see, n minus 1 s square by chi-square alpha by 2 comma n minus 1 degrees of freedom comma n minus 1 s square by chi-square into chi-square 1 minus alpha by 2 n minus 2 degrees of freedom. What are these? These are upper limit and lower limit. So this is known as lower limit and this is known as upper limit. So upper limit, lower limit is also called as left tail and right tail. We all know that. See, I'll tell you. So this is normal distribution. We all know that for normal distribution the mean will be center, exactly center, and this is left tail and this is right tail. Okay, na? So these are also called as what? These are also called as lower tail and upper tail. See here, alpha by 2 here, and here 1 minus alpha by 2 will be. Okay, so this is upper tail and this is lower tail. For normal distribution, the left and right tails will be like this. Okay, one is alpha by 2 and the other is 1 minus alpha by 2. Okay, yeah. So, and these are the confidence limits formula. So in order to find out s square, what is the formula? 1 by n minus 1 summation xi minus x bar whole square. So if you want to find out s square, so at the time what we have to find out first? We have to find out x bar, that means mean. So x bar equals to 1 by n summation xi. So what is xi values? Here they have given no 8.6 and all those. These are the x values. So now we are going to find out that value. So 1 by 9. So what are the values here? 8.6 plus 7.9 7.9 plus 8.3 plus 6.4 plus 8.4 plus 9.8 plus 7.2 plus 7.8 plus 7.5. Okay, so we are going to find out what? Mean value. Okay, so first we are going to add all the x values. So 8.6 plus 7.9 plus 8.3 plus 6.4 plus 8.4 plus 9.8 plus 7.2 plus 7.8 plus 7.5. Okay, so This value is 71.9 divided by what? 9. N value is 9 divided by 9. So that equals to how much? 7 point. So x bar value is how much? 7.9889. Okay, 7.9889 is the x bar value. Okay, so now what we have to find out? Now we have to find out s square. Okay, so what is s square here? 1 by n, this formula, no? Okay, this formula. So for that what I am going to do is 1 by n value is nothing but 9 minus 1, and here for our convenience what I am going to do is x bar I am going to make it round. So 7.9 is nothing but we can make it as 8. Now x bar value is how much? 8. Okay, so 8.6 minus 8 whole square plus 7.9 minus 8 whole square, these values, okay, x values minus x bar values, no, plus 8.3 minus 8 whole square plus 6.4 minus 8 whole square plus 8.4 minus 8 whole square plus 9.8 minus 8 whole square plus 7.2 minus 8 whole square plus 7.8 minus 8 whole square plus 7.5 minus 8 whole square. Okay, so if you want to keep x bar value this one, also you can keep nana, but for my convenience what I made is I made the x bar value round figure. Okay, so that equals to 1 by we calculate all these values. Okay, so the first one is 8.6 minus 8 whole square plus 7.9 minus 8 whole square plus 8.3 minus 8 whole square plus 6.4 minus 8 whole square plus 8.4 minus 8 whole square plus 9.8 minus 8 whole square plus 7.2 minus 8 whole square plus 7.8 minus 8 whole square plus 7.5 minus 8 whole square. See here, the last digits are not appearing. Why? Because the calc will support only up to these digits. So what I am going to do is, I am erasing till here and equals to I am going to place here. That means till here we have did. Okay, equals to this much answer we got. Okay, so place the last one I am going to add. 7.5 minus 8 whole square equals to 7.3500 we got. Divided by how much? Divided by 8. Okay, so the answer is now 0.9188. Okay, so s square answer is how much? 0.9188 we got. Okay, yeah, so now what we have to do is, now we have to find out these limits. Okay, na, upper tail and lower tail. This is called as what, mama? Lower tail. And this is called as upper tail. Okay, ma? Yeah. So for 90%, they are asking us what to find out. 90% only, no? So they asked us to find out 90%. So for 90%, chi-square at alpha by 2. comma 1 minus alpha by 2. Okay, so chi square alpha by 2 means what? Here we get 0.05 comma n minus 1 degrees of freedom. N minus 1, that means what? N minus 1 is nothing but 8 comma chi square 0.95 comma here how much? 8 n minus 1, sorry, here I have kept here 2, here 1 only. Okay, n minus 1, so 8. So how we got these values? How we got these values in the sense, see here 0.05 in the sense 90%. 90% means, as I told you, that 100 minus 90% is nothing but 10%. So 10% here divided by what? 2. So 10% divided by 2 in the sense what? 5%. 5% in the sense what? 5 by 100. That means nothing but 0.05, isn't it? So that's why here we have taken 0.05. But here what they told? 1 minus alpha by 2. That means 1 minus 0.05 is nothing but 0.95. Okay, so now I think now you understand how here 0.05 and 0.95 came. Depends on this. Okay, yeah, like this. Okay, yeah. So now we keep these values in the formula. What is the formula here? N minus 1. Okay, n minus 1 s square. So again I will write here formula for your sake. N minus 1 s square by chi square alpha by 2 comma n minus 1 degrees of freedom comma n minus 1 s square by chi square 1 minus alpha by 2 comma n minus 1 degrees of freedom. Okay, now we will keep the values here. 8, 9, n value is nothing but what? 9. So 9 minus 1 into s square. S square is 0.9188 into 0.9188 divided by chi square alpha by 2. Okay, so first we have to write the table values. Chi square 0.05 at n minus 1 degrees of freedom, that means 8. The table value is 15.507. These are the table values, and for this the table value is 3.490. Okay, so I'll show you in one video, ma, don't worry. Okay, so these are the table values, critical values also we can say. Okay, chi-square distribution critical values 5% దగ్గర 8 degrees of freedom దగ్గర ఇది 0.95% దగ్గర 0.95 level of significance దగ్గర 8 degrees of freedom దగ్గర టేబుల్ వాల్యూ వచ్చేసి 3.490. సో ఇక్కడ మనం వేద్దాం. ఫస్ట్ chi square alpha by 2 అంటే ఏంటి? 15.507. n minus 1 in the sense what? n minus 1 in the sense nothing but 8. That means 8 degrees of freedom. That one no need to keep. Comma. This and next is n minus 1. What is n minus 1? Again 9 minus 1 into s square. What is s square? 0.9188 by 1 minus alpha by 2. That means 3.490. 3.490. Okay? Yeah, we'll calculate. Here 9 minus 1 is nothing but 8. 8 into 0.9188. 0.9188 equals to how much? 7.3504 divided by 15.507 equals to how much? 0.4740 comma again this one 8 into, so already we did know something, we got 7 point something. Okay, no problem, we'll do again. 8 into 0.9188. 0.9188 equals to how much? 7.3504 divided by what? 3.490 equals to 2.1061. These are the confidence limits for the given problem. Okay, so see here. Here n minus 1 is there, no? So why we did not keep n minus 1? You should not think in that way, Nana. We are writing this one at n minus 1 degrees of freedom. So that's why we should not keep these values. Normally what we write, for example, I'm telling you one example. Chi square is there. Chi square n minus 1 degrees of freedom we'll write, no? So like that only. Here n minus 1 already we used. Here we are telling that we are using n minus 1 degrees of freedom. Like that we are telling. That's it. Okay. We should not substitute here again n value. Okay. Yeah. Hope you all understand, Nana. So this is about the confidence limits for what? Population variance. Why we have to use here chi-square distribution? Why? Because here they are asking about population variance. When sample observations are given, if we want to calculate the confidence limits for population variance, at that time what we have to do is we have to use chi-square distribution confidence limits. The chi-square distribution confidence limits are these. Okay, it is a formula for chi-square distribution confidence limits. Hope you all understand, Nana. Okay, so keep watching. So thank you for watching, and also keep watching, share, subscribe, like. Bye, take care.